In this video, you will get to build your very first module. The last lecture was really giving you an introduction to the structure of module files and a bit of a background on C++20 modules. But in this lecture, we will start to try and actually use them. We will declare a module file. The name of the file is going to be math.ixx because this is the extension we are using here. And notice that in the global module fragment, we are using old style includes. Some things can't still be imported, especially on different compilers. I think you can import almost everything inside Visual C++ at this point, but it is not always going to work with GCC and Clang. What I have here is the sweet spot I was able to find to work across all compilers, but feel free to try and import and see how far you can go in your favorite compiler. If you come across errors, please revert back to what we have here because I made sure it can work on all compilers of interest in this chapter here. After these includes, we have the module declaration. Our module is going to be named math stuff. It is a module declaration because we have export module here. If we don't have the export keyword, it's not a module declaration. It is something else, as we will see later on as we progress in the chapter. After this, we have our import. IOStream can be imported across all compilers, so this is going to work. And after this, we have the module purview. In this case, our purview has three functions. We have add, greet, and print name length. And all these functions use different facilities from the thing we either include or import here. Add is going to return the sum of two numbers. Greet is going to print a message, and it is going to try and use std string because we included it here. And the print name length is going to use features from the C string header that we just imported here. And if we import this module file, we should be able to use either of these functions here, and it is going to work in a minute. Okay, here is the main CPP file that tries to import our module. Notice that we are also importing IOStream because we are trying to print things out here. A few facts before we try and run this code here. If a module declaration has an export in front of it, the file containing the module becomes a module interface file. Per that statement, if we go back to our code here, the line here makes this file a module interface unit because it is a declaration of a new module in our C++ program, if I can say it like that. The collection of entities exported from a module file make up the module interface. So in this case, our interface is made up of three functions: add, greet, and print name length, because it is what we export from this module here. This is what we mean. Okay, now that we have a few basics out of the way, let's zoom out a bit and see different ways we have to use modules in our C++ program. The first is include translation. And include translation is what we are doing in our global module fragment here. You will include files as you would have included them in old C++. And the C++ compilers are configured to handle this in a specific way to make it usable inside your module code, and this is called include translation. The other option is header importation, which is what we have been doing all along. If we go back to our code and look at line 8 here, we are doing header importation, and this is what we call a header unit in our C++ program. C++ compilers will compile this header file in a way that it can be treated as a module. That's why we can do this. And the other way is module importation, which is what we have been doing. Once you have a module defined, you will be able to import it like we are doing in our main CPP file here. This is module importation. So we have three ways: include translation, header importation, and module importation, and you will use whatever makes sense for what you are trying to build. Okay, here are a few facts about each of these ways to work with modules. I will let you pause and read about them because it is what we just said. And now that we have these basics, we can actually try and run our module code here and see what we get. Again, as we have done in the last lecture, we will be using the Visual Studio IDE as an editor, and we will be able to compile this code either using Visual C++, GCC, or Clang. And you don't really have to use all these compilers. Use whatever you are able to access on your local system, but I would recommend to at least try a few of these. In the first few lectures of this chapter, I will be compiling with you, but after you have the hang of it, I would expect you to be able to compile by just copying these commands and putting them in your terminal. I will always show you how to do this in the Visual Studio IDE, but when I can't, but to save on time, I may just show you the instructions here and let you compile on your own. We will see what time allows. Let's go to our editor and create a new project and create our new module here. Let's grab the name and steal it. So it is going to be 48.2, your first module. I will create a new project. So file, new project, and it is going to be a console application. And I'm going to give it a name and create it. Save what we had before. And we want to rename this to be main.cpp, as we always do. And what else? We can create our module file. So new item, it's going to be a module unit. It's going to be named math.ixx, as we always do. And we can steal the code. If you want, you can type it, but I am just going to grab the code I have on GitHub here because it's going to be easier. I can copy the raw content, come back in my editor and put in the content. And you can see that we have squiggly lines because we haven't enabled modules. To enable modules, please come back to the project, right click, go to properties, go to C and C++, choose language and choose C++20. This is going to enable modules for you. But you also need to come to general and go to scan sources for module dependencies and set this to yes. Click apply, click OK, and our module should be understandable by the IDE right now. Again, we are not doing anything special. We are just following the structure to create a valid module file. We have our module declaration. On top here is the global module fragment in which we are using old style includes. And in our module purview, we have the exported entities from our module. In this case, again, it is the add function, the greet function, and the print name length function here. Let's grab the code for the main CPP file. So let's grab it, copy raw file, come back to our editor, go in main.cpp, Control A to remove, and paste in the new content. And if we try to build this, let's try to do that, build solution. And if we run the program, we should see the result here. So debug, start without debugging. It is going to print whatever it is we expect here. Now we have this running using the Visual Studio IDE. We can use any of the other compilers we have access to. On Windows here, I have access to a GCC compiler. Let's create a terminal window that we can play with. Okay, now we have our PowerShell window. You can see that it is working in the current directly. Again, if you missed this, I got this by going to View and choosing Terminal here. This is going to open this window for me. And now I have the main.cpp file and the IXX interface file here. We can compile these using any of the supported compilers. If I go back to the GitHub repository, I have instructions to use any of the other compilers. This project is made up of two files, as you see here. If we try to use G++, we can copy the first command here, come back to our IDE and clear and see the version of G++ that we have. You can do this if you want. And we will paste in the command to compile our header unit because it is the first thing that is needed and other files in the project are going to be depending on it. Let's grab the second command to compile our interface file into a C++ file. Again, what we are doing here, we have an option that we are passing to the C++ compiler to treat this file as an interface file, and it is XC++ as you see here. The same idea we really saw for Clang. Let's grab the command, copy, and go back to our PowerShell window and put it in. If we do ls, we should see our object file and we should see a GCM cache folder that was created. This is what contains our module files or our BMIs, if I can call them like that. We can cd into there and see what we have. So let's cd GCM clear and do ls. You see that we have math stuff here, our BMI. If we change into the C folder, we can go there. Why not? and do ls, you see we have MinGW. If you change into this MinGW, you will eventually find the BMIs for the header units that you generated. I don't really want to go there at this moment because this is compiler specific. Now that we have the object file, we can link it. So let's do that. Grab the last command to do that and put that in the editor. And now we should have a Rooster file, as you can see right here. So we can run it. We can say Rooster, and it is going to give the output that we expect from the methods that we defined in our module interface file. Okay, this is how you compile this using the GCC compiler. You can also use Clang on Windows, but you need to do this from the terminal. So let's grab the first command here and come back to our terminal window, developer PowerShell. Let's remove whatever it is we had. So remove r.gcm. We need to let go of that. We also need to remove any object files that we have generated. Can't type, can I? So we have that, and we are clean again if we remove the Rooster file. Now we can go to the command prompt and pass the commands. Again, if you are using the Clang compiler on Windows, you need to go through the command prompt for reasons that we have seen in the first lecture of this chapter. So let's put the command here, making sure we are doing this from the command prompt. This is going to generate our header unit. Let's pass the second command, which is going to compile our module into a PCM file, which is the BMI format for Clang. Let's grab the third command, which is going to compile our main file into an object file and put that in our prompt here. This is going to give us the object file. Let's grab the other command, which is going to compile our module into an object file. Again, it is going to give us the object file here. And the last thing is going to link everything together and create a binary named Rooster. Let's try to do that. And now we have a Rooster file that we can run. If we do Rooster, it is going to run, and we have the results here. You can also use the Clang compiler, which is embedded in a Docker container. For that, let's create a new PowerShell window, and we will connect to our Docker container. Let's do that. Docker container Clang Hank can do that. And now we can cd up and go into 48.2. This is going to take us in the current project, and we can run the commands to compile with Clang. Let's do ls alh and remove any PCM files and remove any object files and remove Rooster. Now we have a clean slate from which we can compile using the Clang compiler embedded in our Docker container. Again, the commands are here. So copy the first command, which is going to compile our header unit. Let's put that in here. And we want to grab the command that is going to compile our module. Let's put that in our terminal here. Grab the command that is going to compile your main file. Put that in the terminal here. Grab the command that is going to compile our module into an object file, and we put that in place. And the last one is going to put everything together and create a binary named Rooster. So let's do that. And if we run it, it is going to give the expected output here. Again, you don't have to use all these compilers. I am showing them all so that you have options, especially if the Docker option is confusing to you. Use whatever compiler you have access to, but I want you to have as many options as possible. This is really all I had to share in this lecture, showing you a good example of how you can create your own module. Our module is made up of this interface, and an interface is made up of things that you export from your module. I am going to stop here in this lecture, and I will see you in the next one.